Now we will continue with the surface chemistry. In the surface chemistry, the next part is your adsorption isotherm. Adsorption isotherm. So what is adsorption isotherm? Adsorption isotherm, also called as what you can say, describes the, also called as adsorption isotherm, same thing. So describes the equilibrium of the sorption of a material at a surface, more general at a surface boundary at constant temperature. You can see it is there on the screen at a constant temperature. It represents the amount of material bound at the surface as a function of the material present in the gas phase and or the solution. Okay. Now, what do you mean by this? The meaning is that the extent of adsorption on a given surface, generally it increases with certain factors. Increases or decreases with certain factors. Listen carefully. The extent of adsorption on a given surface, it generally increase or decrease certain factors. Now what happens is here that suppose if we increase the pressure of gases or the concentration of solution at a constant temperature, two different things. One is for the pressure of gas, another is for the concentration of solution. It is two different things. Alright, at constant temperature. Now what you find is at low temperature, the physical adsorption of a gas increases rapidly as the pressure rises. Why low temperature? Because in adsorption process is exothermic in nature. See, if we increase the temperature, the reaction, instead of going in the forward direction, it will become reversible. It will go in the backward direction. That means adsorption is going to decrease. So if you want to increase the physical adsorption of a gas, then the temperature has to be kept low. Remember this always, because the adsorption process already we have discussed, it is exothermic in nature. So at low temperature, the physical adsorption will increase when the pressure increases. Got it? This is, you have to remember it. When the temperature is high, just now I said you that the pressure, even if you increase the pressure, the absorption process is going to decrease. It will be relatively less, so to say. Got it? So the surface area per gram of the adsorbent, means the adsorbent is a surface where it is adsorbed. Now it is in the form of powder, or it is in the form of porous substance. We can say that porous, holes are there. Got it? Or in the powdery substance, is called its specific surface area. That is known as specific surface area. The surface area per gram of the adsorbent. Per gram. Simply if I say surface area, then it is known as surface area only. But when I say per gram, got it? Then it is known as specific surface, because I am specifying it per gram. Got it? It is expressed in square meters per gram also. Yeah, that's also can be taken off. Now, highly active solids with large surface area, it acts as an adsorbent. We can say that it acts as an adsorbent. So this adsorption data, got it, we are representing it by some regression analysis. The most frequently one is your linear isotherm. The one which you are going to study is your Freundlich isotherm or Langmuir isotherm and the BET model. So we don't have to study the Langmuir and the BET model now. We are going to study only the Freundlich isotherm. We are going to study about it. Alright. So the next is your, what is the adsorption isotherm? We'll come to the definition. Now we have understood what is adsorption isotherm. That is nothing but the extent of adsorption on a given surface. Alright. It depends upon certain factors. One is pressure, another is your pressure of the gas, another is your concentration of a solution at a constant temperature. Now when a graph between the amount of the gas adsorbed per gram, just now I said you, that is specific adsorption, specific surface area. A graph which is between the amount of the gas adsorbed per gram of the adsorbent, which is X by M, and the equilibrium pressure of the adsorbent at constant temperature is called the adsorption isotherm. That means when you are drawing a graph between X by M and pressure. Now see the graph. That is this particular graph. See the extent of adsorption X by M and pressure is in the X axis. When you are drawing a graph between X by M and pressure, then that particular isotherm is known as adsorption isotherm. Now remember, isotherm means temperature remains constant. Here the temperature has to be constant. So if the temperature has to be constant, then it will depend upon pressure. Suppose when I say adsorption isobar, then what it will be? Pressure remains constant. When I say adsorption isobar, let us say I am saying adsorption isobar, then what do you mean by that? So understand it, the things. It's a graph between the amount of gas adsorbed per gram of the adsorbent X by M and the equilibrium temperature and what you can say of that is nothing but equilibrium pressure at a that is at a constant pressure. We can say that equilibrium temperature of adsorbate at a constant pressure is called the adsorption isobar. So instead of temperature you will be using the pressure there in case of isobar, so that you understand it first. So here I am drawing a graph between extent of adsorption on the surface, alright, that is x by m per gram, we can say that in respect to pressure. Now what you see in this particular graph, see what you see in this graph, the graph which you are seeing in front of you on the screen, what do you see here? You can see that is one PS is written there. What is that? It is equilibrium pressure, that is known as x by m, already said you. Now it is nothing but the amount of substance or the gas which is adsorbed per gram of the adsorbent, that I have already said. Now see what happens at value PS of equilibrium pressure, x by m reaches its maximum value. Can you see it there? The x by m is maximum there. The graph is increasing. So maximum it reaches at that particular point. After that you can see the graph becomes almost a straight line. Can you see? That is PS when the x by m reaches the maximum value. So hence that particular pressure is known as saturation pressure. That means you are increasing the pressure. What I said just now, when you increase the pressure, keeping the temperature constant, the adsorption rate increases. But it will increase to a certain extent. It will not going to infinitely, it is going to increase. It will increase to a certain extent. So that particular point is known as, in terms of pressure, is known as equilibrium pressure or saturation pressure or saturated state, whatever you can say. It is represented by PS, where the x by m value is maximum. That is, the amount of gas adsorbed per gram of the adsorbent is maximum. We can say that. Clear? Now, next is, based upon this particular graph, we will now try to draw a relationship between them. You can see the three areas I have marked it here. One is x by m is equal to Kp, one is x by m is equal to Kp1 by n, another is x by m is equal to Kp to the power 0. So what you find is that here it depends upon the pressure. In the Freundlich adsorption isotherm, you can see the pressure is changing. Now what do you find? The first one, that is the first one, x by m is equal to Kp, that I am discussing with you. Now see, when the pressure is low, when x by m is equal to Kp, the pressure you can see it's very low. When the pressure is low, the graph is nearly a straight line. The graph is nearly straight line, we can say that. Clear? So in this way, now this is represented by the following equation, x by m is directly proportional to P, because if it is a straight line means x by m is directly proportional to pressure. Got it? So hence, to remove the proportional sign, we are taking a constant, which is nothing but known as K. So x by m is equal to Kp. Done? Fine. Now at high pressure, when the pressure increases, when the pressure is high, that is saturated, PS. When the pressure is high pressure, then what you find is that, listen carefully, x by m becomes independent of the value. How you say it is independent? Because see, if you increase the pressure, the graph is not increasing, the graph is a straight line. Can you see? PS. Got it? PS you have drawn, I have drawn a straight line there. After that you can see the graph becomes a straight line. Got it? That means if you increase the pressure further beyond PS, if you go, then x by m value is not going to increase. That means here the pressure becomes independent, because by increasing the pressure, listen carefully, by increasing the pressure, x by m value is not increasing, it is a straight line. It is independent, we can say that. Clear? So hence here P to the power 0. In the first case, a dotted line, you can see here the graph is almost a straight line. That means pressure is increasing, x by m is increasing. So hence it is directly proportional. In after PS, if you see, the graph is a straight line here. Now this straight line difference is there. Here it remains constant. X by m value remains constant. That means if you increase the pressure, x by m does not increase. That means pressure is independent here. So P to the power 0. Got it? Now in the intermediate range, got it? Between the dotted line, you can see a straight line is there. There is an intermediate range. Got it? Between pressure is equal to 1 and pressure is equal to 0. Between 1 and 0, what do you find? An intermediate range. Got it? So there is a small change in pressure if it's taking place, then it is a fractional. That is, a P is raised to, between 1 and 0, the value P remains, because in the first case it is 1. In the second case, in the last case, it is 0. So in between that 1 and 0, the value of P will remain. So hence it is 1 by n for that particular purpose. Is it clear? That is x by m in between the straight line which you can see, which is not a dotted line. The value will remain between 1 and 0. So 1 and 0 means it will be fractional. So hence it is said to be as 1 by m. So here that is x by m is equal to kp 1 by n. We can say that, where n is a positive integer. Got it? K is a constant. Of course you know that. Clear? So in this way, this is the adsorption isotherm we came to know. That is when the pressure is low, the extent of adsorption is higher. So it is directly proportional. After that, when the pressure increases at a saturated pressure, even if you increase the pressure further, then the x by m value does not increase. That means the extent of adsorption does not take place. It is becoming independent. So in between, what you find is that between 1 and 0, the value is fractional. Which value? The p value is fractional. Temperature is constant here. Remember it is an isotherm. Temperature remains constant. So hence, what we get it, an equation ultimately x by m is equal to kp to the power 1 by n. We got it. Clear? So this is known as Freundlich adsorption isotherm. Now this particular one we can show it, that is graphically we can show it, this particular in the form of log we can show this particular value. Yeah, it is here. In the form of log you can see this. I have shown it here, that if you take log both sides, then what you will be getting? Log x by m is equal to log k plus 1 by n log p. Got it? What is the equation you got? X by m is equal to kp to the power 1 by n. Take log both sides. Log x by m is equal to log k plus 1 by n log p. So that I have represented in a graph again. Alright, I have taken log x by m on the y-axis and log p on the x-axis. I have taken it. You can see the intercept is log k and the slope will be 1 by n, because you just equate it now. Y is equal to mx plus c. When you equate it to y is equal to mx plus c, then y is your log x by m and c is your log p. So m will be what? 1 by n. Alright. Sorry, x is your log p. Sorry, I'm very sorry. Y is equal to mx plus c. Y is your log x by m. X is your log p. And c is your log k. As you can see, intercept. Y-intercept, that is log k. Then what is the slope? So slope is equal to y is equal to mx plus c. If you do, then m is equal to 1 by n. You got it. So in this way, we can convert the Freundlich that equation into the logarithmic form. In this way, we can convert it. Done. We can convert it in the logarithmic form. We can do it. Got it? Now this particular one, if you see, now previous equation which you have seen it, in the previous equation, I have given you a relationship between pressure and x by m. There was a relationship. X by m is the amount of gas adsorbed, got it, per gram, isn't it? The surface area, the specific surface area we have taken it, the amount of gas that is adsorbed per gram of the adsorbent. That is nothing but x by m was taken there. Got it? Clear? So that is amount of gas adsorbed. Here instead of that, the gas, what I am saying, instead of gas I am taking here concentration. So when we will take concentration, x by m kp to the power 1 by n, instead of that what you will have? X by m is equal to kc to the power 1 by n. See here, x by m is equal to kc to the power 1 by n. You will say that from that QE is coming. Here QE is taken to be as x by m. Instead of x by m, here it is taken to be as QE, because there x by m was the amount of gas adsorbed per gram of the, what you can say, adsorbent. Here QE is nothing but the amount, that is nothing but amount of solution adsorbed per gram of the adsorbent. You can say that the amount of the solution adsorbed per gram of the adsorbent, which is represented by Q. You can also put x by m, no problem, but you can also take a different unit also, symbol also you can take it, that is QE. So what is the formula now? Instead of x by m is equal to k into what you can say, k into p to the power 1 by m, instead of that what we will say, that is nothing but QE is equal to, or x by m is equal to k into c to the power 1 by m. Or as you can see in this particular on the screen, QE instead of x by m I have taken it as QE is equal to kf. Kf again is a constant, proportionality constant, into c to the power 1 by n. We can say that c to the power 1 by n. And here E, what you are seeing it, what does it E stands for? Equilibrium. That is the equilibrium, when the amount of substance which is adsorbed. Alright, there we are saying equilibrium pressure. So it is nothing but when it attains equilibrium, when the system attains equilibrium, isn't it? What was the adsorption isotherm definition? A graph between the amount of gas adsorbed per gram of the adsorbent and the equilibrium pressure. So here instead of that you will be saying the equilibrium, that is nothing but concentration. Understood? So in this way This is another case of Friend-Delitzsch adsorption isotherm when instead of gas a solution was being taken. You can see it is written there, for the special case of heterogeneous surface energies, particularly good for mixed weights in which the energy term Kf varies as a function of the surface. So same thing it is, the meaning is the same here. N and Kf are what? That is nothing but N is the positive integer and K is a constant. Instead of K it is written as Kf, and E stands for equilibrium, we can say that. Clear? So this is a graph you have understood, and this again when you convert that Q E is equal to Kf into c to the power 1 by n, when you convert it into logarithmic form it comes to be this, that is log QE is equal to log Kf plus 1 by n log C. Understood? It is converted, the same equation QE is equal to Kf into c to the power 1 by m, that equation again comes to be as log QE is equal to log Kf plus 1 by n log C when you convert it in the logarithmic form. And same graph you can draw it here, instead of log x by m, what you will write it at in the y axis? Log QE. Instead of log P in the x-axis, what you write it as? Log C, because concentration. So when you compare this equation with y is equal to mx plus c, what you will get? Log Kf as the y-intercept, that is your c, and 1 by n is the slope. Slope as 1 by n. When you equate it, y is equal to mx plus c, then you will get this particular value. Now, what are the factors which affects the adsorption from solution? Nature of the adsorbent and the adsorbent. Definitely, it depends upon the nature of the adsorbent and the adsorbent. Means what? Now, solid surface can also adsorb solute from the solutions. We know that. Solid surface, it can adsorb solute from the solutions. So, suppose, example, you have taken a litmus solution and it is taken with charcoal. Listen carefully, you have taken a litmus solution, that is adsorbent, you have shaken with charcoal, adsorbent. It becomes colorless, litmus solution. Suppose if it is a blue litmus, it becomes colorless, or red litmus, it becomes colorless, because the dye of the litmus solution is absorbed by the charcoal. The dye, the color of the litmus solution is absorbed by the charcoal, we can say that. Similarly, when a solution of acetic acid is shaken with charcoal, some amount of acetic acid from the solution is absorbed on the charcoal, adsorbed, and hence the concentration of acid in the solution will decrease, because if acid will be absorbed, then the concentration is going to decrease. Got it? So in this way it depends upon the nature of the adsorbate and the adsorbent, how good the adsorbate and the adsorbent is. Suppose instead of charcoal if I use another, and definitely the adsorption power is going to decrease. Another means if you take silica gel, or if you take let us say that is starch or something like that, then definitely is going to decrease. It is going to change. The adsorption decreases with increase of temperature, that already we have discussed, because adsorption process is exothermic. So if temperature will increase, adsorption is going to decrease. Greater the surface area of the adsorbent, greater is the adsorption, definitely, because if the surface area is more, the adsorption power will be more, because adsorption depends upon the surface area. We have just learnt it. Specific surface area means per gram. Got it? So a graph between the amount of the gas adsorbed per gram of the adsorbent x by m and temperature T at a constant equilibrium pressure of the adsorbed gas is known as adsorption isobar. Now this is adsorption isotherm I was talking. I have already told you earlier also. Suppose if it is adsorption isobar, then what should be the definition? I said you at that particular time that instead of pressure we will be using the word here temperature. Now we are having two adsorption isobar. Sorry, it is physical adsorption osobар it has become. It is not osobar, it is isobar. Instead of O it will be I. That's a spelling mistake. You can correct it. So physical and chemical adsorption isobar, which is known as physioption and chemisorption. These two graph represents physioption and chemisorption. So what you find is that here when the graph is drawn against temperature, in both the graph you can see pressure remains constant. It is drawn against temperature because it is an isobar, remember it. So in case of physioption, the value decreases. When temperature is increasing, the x by m value decreases. Just now I have told you why, because the reaction is exothermic. Instead of the reaction, if you increase the temperature, then what will happen is that the reaction will favor in backward direction. So hence x by m, that is the amount of gas adsorbed per gram of the adsorbent, is going to decrease with the increase in temperature. You can see that is called physioption, the first graph. In the second graph, what you see, first it increases and second it decreases. Can you see there? X by m, first it increases. In chemical adsorption, first increases the graph, and see the graph reaches the peak, then after that it decreases. Why? Why it is so? Because in case of chemisorption, initially an increase with temperature increases the activation energy. Alright, increase here when the what you can say temperature increases, you reach to the, that is you provide the activation energy. So hence there is, the graph shows an upward trend. But after that, when the activation energy is being used up, when you reach to the activation level, when you reach to the threshold level, if you increase the temperature further, then the amount of adsorption is going to decrease. Alright, again I repeat. Here in case of chemisorption isobar, you can see first it increases. Initially it shows increase with temperature and then it decreases. Why? The initial increase is because of the fact that the heat which you are supplying it, it is used for the activation energy to reach to the threshold level. After it reaches threshold level, it is what you can say, the reaction, it's reaching to the peak. Alright, then after that the reaction does not carry out in the forward direction. The reaction, it carries out in the backward direction. Now if you increase the temperature, for that purpose first the graph increases, then the graph decreases. So initially why it increases? Because the heat is required which acts as an activation energy to reach to the threshold level. Once it reaches threshold level, even if still you provide, you know the reaction is exothermic, even if still then you provide, the reaction will proceed in the backward direction. So hence it shows in the backward curve. We can say that the downward curve, rather not backward, downward curve, you see it here. So this is your graph adsorption isobar for physioption or physical adsorption and chemisorption or chemical adsorption. Okay, so this is all about